Welcome, and thank you for joining this webinar, From Connectivity to Sensing Revolution, How Wireless Can See the Invisible, prepared by Alpert Research Team. Today, we're exploring how wireless sensing isn't just another buzzword, it's the fusion of communication networks with environmental awareness, turning everyday Wi-Fi routers and 5G towers into silent sentinels that detect motion, monitor health, and optimize cities without adding hardware.
But what are the enabling trends on the horizon that might help overcome these hurdles? What does the longer-term roadmap look like for making this technology more robust and capable?
There are several exciting areas of research and development. First, the concept of meta-surfaces, or more broadly, Reconfigurable Intelligent Surfaces, RIS. These are essentially engineered surfaces, maybe integrated into walls or objects, composed of many small elements that can electronically alter how they reflect or refract radio waves. They can be dynamically controlled. RIS technology holds the promise of allowing us to actively engineer the radio propagation environment itself rather than just passively reacting to it. We could potentially use RIS to suppress harmful multipath reflections, focus signal energy where it's needed for sensing or communication, and generally improve both coverage and sensing fidelity. The continued push towards terahertz sensing. Maturing the technology to reliably operate in the Terahertz bands could unlock that potential for millimeter or even sub-millimeter resolution imaging and extreme sensitivity, opening doors for entirely new diagnostic or analytical applications.
Traditional positioning like GPS or even far-field beamforming gives you the 3D location, XYZ. The three additional dimensions in 6D positioning refer to the orientation or the attitude of the source object, its pitch, its roll, and its yaw, which is like its rotation around the vertical axis. By carefully measuring the complex curvature of that arriving wavefront across all the elements of the large antenna array, something that's only really possible and meaningful in the near-field algorithms can estimate the angular rotation of the object that reflected or emitted the signal.
That's transformative for applications, I imagine. Things like advanced robotics needing to know exactly how a component is oriented.
Or immersive VR systems needing to track head orientation precisely. Or building highly accurate digital twins of physical environments, which require not just the location of objects, but their precise attitude as well. 6D positioning unlocks that.
Looking at the business model evolution, we're likely to see the infrastructure itself evolve towards offering sensing as a service. Network operators or platform providers might start selling generalized, anonymized sensing data streams or specific analytical services like occupancy monitoring or traffic flow analysis derived from their networks, potentially leveraging those large-scale foundation channel models we discussed earlier to provide robust insights across wide areas. And looking at the overall network architecture, how will sensing scale across large areas in the future?
The vision is moving towards advanced collaborative sensing, often discussed in the context of cell-free ISAC. Instead of users being served by just one base station in a cell-free architecture, many distributed access points, APs or base station elements, cooperate simultaneously to serve users and perform sensing across a wide area. It enables powerful multi-static sensing. You have signals being transmitted and received by many different points, looking at the target from multiple angles simultaneously. Combining these diverse, uncorrelated observations significantly enhances sensing accuracy, improves coverage, fewer blind spots, and makes the system much more robust to fading and blockage compared to single-point sensing.
The big strategic takeaway seems clear. We're really moving beyond just connectivity. We're turning signal interference, which used to be a nuisance, into valuable insight.
So what does this all mean? The message is clear. This wireless technology isn't just enhancing networks. It's enabling a sensing revolution that redefines interaction with the physical world. Interested in gaining a deeper understanding of the transformative power of wireless technology? Join the Alpert Research Team's webinars to explore cutting-edge wireless innovations, their applications, and their implications. Click the links below to learn more.